Think about your college diploma. If you had to stamp a real-world expiration date on the knowledge it represents, what year would you print? An engineer graduating in the 1930s could build a 35-year career on the foundation of what they learned in school. The facts stayed relevant. This line chart shows knowledge half-life. In 4 years, half a tech freshman's memorized facts become obsolete. Medical knowledge is more extreme. In 1950, information doubled every 50 years. By 2020, it takes just 73 days. Doctors return from vacation to entirely new protocols. We are living through an exaflood, a constant, overwhelming deluge of new data. Because of this, the classic educational model where a single expert pours facts into the passive minds of students simply breaks down. The problem isn't that human intelligence is declining. It is a strict issue of physics. A finite mental container cannot possibly hold an exponential flood of information. Two researchers, George Siemens and Stephen Downes, sketched out a survival strategy for this data flood on a bar napkin. They called it connectivism. Connectivism views knowledge as a distributed network of connections. Under this theory, learning becomes a matter of building and navigating these external links between people and data, rather than relying solely on biological memory. To see how this external learning works, imagine a physics experiment. Dozens of randomly ticking metronomes placed on a wooden board, which is resting on a couple of rolling soda cans. Initially, it's chaotic, but within a few minutes, the physical motion of the moving board transfers the kinetic energy back and forth until the metronomes snap into perfect synchronized rhythm. There is no conductor directing them. In the connectivist model, the students are the metronomes. The moving board is the shared digital environment they operate in, like a chat room or a forum. The synchronization itself is the act of learning. Within this framework, the smartphone functions as an exocortex, a digital extension of the mind that actively routes these network signals into a student's workflow. Forcing a modern professional to solve a problem without access to their digital network is the equivalent of demanding a temporary lobotomy. The modern mind relies on external connection to function at capacity. You might wonder how a theory born on a napkin applies to a rigorous, hard discipline like structural engineering. A university in Malaysia tested exactly this. They took away the traditional step-by-step lab manuals from their engineering students. Instead, they gave them open-ended, messy mechanical problems and completely unrestricted smartphone access. Faced with unfamiliar broken machinery, the students formed chat groups. They consulted their peers, they searched forums, and pulled data from the network. They learned to diagnose unscripted problems on the fly, instead of passively waiting for a professor to hand them the correct answer. The same mechanics apply to the humanities. Two professors, one in Austria and one in India, wanted to teach cross-cultural communication, but they knew standard lectures usually just reinforce stereotypes. They paired their international students up digitally and gave them a simple task. Find an everyday, mundane advertisement for soup from your home country and ask your partner to describe exactly what they see in it. An Austrian student looked at their local ad and saw family warmth. The Indian student looked at the exact same image and interpreted the cultural cues completely differently, exposing hidden biases neither student realized they had. The actionable insight wasn't written on the professor's syllabus. The knowledge spontaneously generated in the friction and the direct connection between those two students. Human memory can no longer outcompete AI or a digital encyclopedia for factual recall. If your primary value is simply remembering facts, you will lose to the algorithm. This reality necessitates a new role, the network architect. This position focuses on the active curation and routing of information, ensuring high-quality data reaches the right nodes. An architect acts first as an aggregator, filtering out the ocean of digital garbage to find reliable sources. Then they act as an amplifier. When a student or colleague shares a strong idea, the architect boosts that signal to the rest of the network. They also serve as a sense-maker, stepping in to find clear patterns when the group gets lost in the noise. Finally, the architect acts as a network node themselves, learning publicly and transparently to model the exact process for others to follow. Stop writing isolated essays or reports that get filed away in a drawer. Start publishing your ideas into the real world, whether on a professional blog or a public forum, to actively build a web of resources. We live in a world where new facts expire in 73 days. Professional survival depends entirely on building the strongest connections, not having the biggest memory.